A little bit of an introduction on what is open source and why is it being used within shipping products that we're building, and we'll talk a little bit about the risks and challenges that we inherit as a result of using open source. We're going to walk through some steps to build your OSS bill of materials, which is a catalog of all the OSS being used in your product. We'll gather threat intelligence so that we can actually go and remediate vulnerabilities and start managing that risk. And we'll take some steps to mature the process along the way. So quick background on myself. I've spent the last 5 years at BlackBerry product security. Most of that time has been in the product security incident response team. So we're responsible for managing any externally known or publicly known vulnerability that could potentially impact our products. So a huge part of our scope is open source. And I don't know how familiar anyone is with kind of the modern BlackBerry, but we have a big portfolio of enterprise software. We have about 80 different SKUs. We have operating systems and iOS apps and Android apps. I think we have a Windows Phone app somewhere. We have servers and all kinds of stuff, kind of one of everything. So a really broad set of products, and we have a really broad set of open source that we need to manage. So I'm going to be using the terms open source software, libraries, and OSS pretty interchangeably. But what is an OSS library? So it's a publicly available software package that solves a common engineering problem. It's a problem that's not really specific to any given app. And we can see that captured here in some of our example libraries. So we have OpenSSL, secure networking, and we have libtiff and OpenJPEG, which does image parsing, and libxml2, which handles XML parsing. These aren't necessarily things there's a lot of competition for in today. I found this quote from a guy named Carl Grant, and it says, open source makes sense when a software product reaches commodity status. And I think that rings true for a lot of the examples here and a lot of other functions that we'll find captured within open source packages. I think a lot of the times we're just looking for interoperability when we're pulling these things in, so it's great that we do have open source to have that common solution available. So you're definitely using open source one way or another. If you're building a large software product, you're probably using open source. You're definitely using it on your smartphone, probably your desktop as well. If you go digging deep down into some of the licensing information on any product that you use, you'll hopefully find the licenses for the open source projects. It is a requirement to keep those licenses in there, so certainly hope that they're there. But if you go and dig through that, you'll get an idea of what is being used in whatever product it is that you're using. So I think it's a common misconception that open source is free. Yeah, it's freely available to go and download up front. Everything after that is a cost, though. So figuring out how to call the APIs, figuring out how to compile the library, figuring out how to configure the library can be pretty expensive. And then the biggest expense is maintaining that library over the course of its useful life within your product. Bug fixes and vulnerability fixes. And the useful life of that library is probably the useful life of your product. These examples here, that's pretty core functionality. The only time I've really seen libraries removed from products after they ship to market is if a duplicate copy was found somewhere. So quick disclaimer before we go any further. We love open source, we use a ton of it, and I don't think we'd be able to ship modern product without it. So nothing we talk about today is meant to point fingers or lay blame to open source projects that are building libraries. Vulnerabilities happen everywhere. It's code you write yourself, it's code your suppliers wrote, open source projects, you paid for it, you didn't pay for it. Whatever the situation is, there's vulnerabilities. We're focusing on open source here. And we love open source, we want to keep using it, we just want to use it in a mature way and start managing some of these risks. So out-of-date libraries, it is a really big problem if you take a week off to go on vacation or come to a conference. By the time you get back to your desk on Monday, there will be more vulnerabilities. I know I've got some waiting for me now to go and assess. If you go a year without managing your OSS debt, you're racking up potentially hundreds of vulnerabilities. There's a really interesting example at this link of the Project Zero guys caught one of the AV vendors who were shipping a common component amongst all of their products, and within that component had a bunch of open source that hadn't been updated in 7 years. So they had hundreds and hundreds of vulnerabilities, and dozens of those vulnerabilities had multiple public exploits available for them, so you could just fire up Metasploit and just go to town on them. It's a pretty egregious example, but it's not specific to this company. I mean, there's a lot of companies that are not managing this stuff. These guys just happen to get caught here. So a little bit of data from my team, my company. We have, as I mentioned, we've got about 80 SKUs. And across all those SKUs, we found about 600 unique libraries that we're using. That number changes constantly. And any one of those unique libraries could be used in multiple products. And even within one product, you might find that same library a number of times. And when you multiply all the instances of those libraries together, we came up with about 8,000 different instances of a open source library being used. And when we measured the number of vulnerabilities that appeared in those libraries last year, we had about 20,000 different potential vulnerabilities. So they weren't all confirmed vulnerabilities, lots of false positives, but that's 20,000 different line items that needed to go and be investigated over the course of last year. And that's just open source. So I created a bit of an example product for us to look at today, and I think this is pretty typical of what you'd see in the wild. So this would be some service that's offered on iOS and Android, as well as on the desktop apps, and also through a web app. So 100 libraries approximately, resulting in about 300 vulnerabilities over the course of a year. I think in general, vulnerabilities kind of follow the 80-20 rule, so you're going to find 80% of your vulnerabilities in 20% of your components. There's some very busy open source projects, and there's some others that still haven't been an announced vulnerability in them. The weight is heavily weighted towards the server side. So you'll see a lot more OSS there than you would on the client side, which is good for us as defenders. It's a lot easier for us to update our infrastructure than it is to compile and ship a client and then hope that our customer takes the update. And then if you're building something like embedded, you'll probably find a lot more OSS at the OS level than you would at the client level. So there's a lot of challenges with integrating open source within your own products. Obviously, the obvious one is number of vulnerabilities. There's a lot of them. The velocity is growing year over year. It makes it hard for us as defenders to keep up. As we mentioned, open source gets used in our products. It's a known working solution to a common problem that a lot of us will face. But in my experience, oftentimes libraries will get pulled into products without any kind of security assessment in advance. And really, if you're building a service and you're using 100 different libraries, how do you audit all of that code in advance? And some of those libraries are absolutely massive. Other things to think about is, do the open source projects that build those libraries have an incident response plan? And do they have experience doing coordinated disclosure? And if so, what is their track record? From what I've seen, it's generally good news there. I mean, I think all in all, open source projects are doing a great job of this. But these are the kind of questions you need to ask, because it's not always going to be the case that they do have an incident response plan. And it's not always the case that open source that you find in your products is actually supported by the project anymore. There are dead projects which are no longer being maintained, which means there's no longer vulnerability fixes being pumped out. So as a responsible user of that open source library, you're going to have to go out and create your own fixes. It doesn't sound like a big deal, creating a fix, not the end of the world, but there's a big skill difference in being able to read a doc and call the API and having to dive in under the hood and start playing with code that you didn't write yourself and you're not familiar with. So it's not the end of the world, but it's not as easy as it might seem. And given that, if you're just starting your open source journey, your products are already in market, you don't really have a say in what libraries are going to be used in the products because they're already there. But these are definitely the kinds of things you should be thinking about for your next generation of products. Get in early, get in design with the development teams, and help them make some smarter decisions. The thing that I think is the biggest challenge from a defender's perspective is the coordinated disclosure process. So as the integrator and the user of a library, everything is out of your visibility until a vulnerability is publicly announced. And that's kind of tough to handle, right? So the process generally follows the coordinated disclosure process as it would be with a software vendor, but the outcome's a little different. So researcher finds a vulnerability, reports to the open source project creates a patch, puts out a library upgrade with that patch, does an advisory to announce that, hey, there's a problem, here's how you fix it. And that's great. That checks all the boxes of coordinated disclosure, but at that point, we've just got caught off guard, and no end customer who's actually in possession of that open source library on their device or their app, or whatever you're shipping, no one has the fix, no one's protected. So, everyone's following the process as it is today, which is good. I just think the problem is a little bit different between direct disclosure with a software vendor and a researcher versus researcher and an open source project. So there are a few different industry working groups out there right now looking to solve multi-party disclosure. I don't know the solution off the top of my head, but it's definitely a problem we need to solve as a group. But these are the risks and challenges that you inherit as a result of using open source. This is what you need to accept as part of the cost. And what we're going to do is start designing some steps and some processes around this so we can start managing some of this risk. So who at your company is actually managing open source? I think in a lot of circumstances the answer is no one. Other times, the answer is more interesting. I actually was surprised to find out that there are a lot of lawyers that are looking at open source. They're not necessarily interested from a vulnerability perspective, but they're there for compliance, legal compliance for the licenses. But you might be surprised to find a pretty powerful ally in your legal department for this stuff, which is really cool. But tracking open source is pretty difficult, depending on how your development efforts are divided, how big your products are, your projects. If you have development teams spread across the world and you have different repositories that at the end of the day are all being tied into one shipping product, it wouldn't be surprising to me if someone had a repository that they didn't actually know shipped to the customer from a security perspective. And if you're a security practitioner, you don't know that there's a repository out there that is shipping, you can't actually manage that open source. So big projects can be kind of scary. But if you're not addressing OSS right now, wouldn't feel too bad about it. As we looked at before, there's some very, very, very large companies that are doing nothing about this at the moment. So we're going to walk through a few steps that you can take to start managing that security debt, start managing that risk, and start proving a lot of value for your company. These steps are applicable whether you're from a product security perspective where you're securing products that you're building and shipping and selling to customers, or if you're building apps that you're deploying internally in your network. These steps all apply. So first thing we're going to need to do is build the BOM, the bill of materials. So this is a big catalog of all the open source that's being used in all of your products. We generally do this by product family. So if we think back to the example from earlier of the service offered across the multiple platforms, that would be a product family. We want to thoroughly go through and catalog that before moving on to the next product family. And as I mentioned last slide, the lawyers could be a really good ally here. So as a first step of BOM building, why do work that you don't have to? If the lawyers already have this list, let's go talk to them. They're not always going to have it. I think probably more often than not they won't have it, but it's definitely a good first step to talk to them. And if they don't have it, you're starting from scratch, and that's okay too. Start with what you know, right? Start writing down and making a list of the libraries that you know are used there in your products. Search through your project trackers or your wikis to find hints about what else is being used. I've seen before, we use Jira in most instances. I've seen dev teams set up custom components in Jira for each library that they're using, each OSS library. So there's a nice free BOM right there in Jira. At some point you want to sit down with your development team and start mapping out all the functions, all the features that your product has. Specifically, architects are usually pretty handy with this stuff. And start asking yourselves, did we build this feature, or would we have used an open source library? And we can think back to our quote from before about, once a piece of software reaches commodity status, open source makes a lot of sense. So let's say we're parsing TIFF files. Would we build a custom TIFF parser? Is that a problem that's specific to our app? Probably not. Has that been something that a lot of different people have needed to implement over the last few decades? Yep. Can we go out to Google? Can we just search for OSS library TIFF parser? We certainly can. We'll come up with libtiff and probably a couple other implementations. So if you can get that far, developers can use Google too. So if they're, why would they go and implement a custom TIFF parser when there's one easily and freely available, right? So at this point, we should consider it highly likely that libtiff or similar is being used. Last point I'll make, build systems are actually pretty handy as well. We use Jenkins in a few different spots, and I've seen Jenkins log the output from the shell during the build process and then store it in a text file. It's really easy to go in there and find the names of libraries if you already know the names of the library you're looking for. A little difficult if you're going fishing. But if you can go on the internet and find a big list of library names and start matching that against the Jenkins output or similar, you'll find a lot of really useful data. So here's an example bomb. It's pretty condensed, but we've got the name of the library, the version that's in use, where we found the library, what license it's being used, and I'll mention the license isn't really impactful for vulnerabilities, but if we're going through all this effort to source this data, let's just grab the license while we're here and give this to the legal team afterwards if they don't already have it. That's a good way to make a friend in legal. And then we've marked all of the different variants that are actually using this library. So the BOM is the kind of the core data that we need to move forward, but the BOM on its own, it's kind of boring. Doesn't really tell us too much. But when you start pairing it with threat intelligence, it's when the magic starts to happen. And when we say threat intelligence, we're not really talking about like IOCs or signatures or anything. We're talking about reports of vulnerabilities in open source software. Since this is, we're trying to take free steps here, it's a grassroots endeavor. We're going to use free sources of threat intel. So we can start with doing things like setting up Google alerts for all the libraries that we're using. You can sign up for mailing lists. So a lot of the larger projects will have security-specific mailing lists, which is great to cut down some of the noise. For a long, long time, we used the Linux distribution advisories as threat intelligence. I think Debian specifically is amazing. If you're using lower-level libraries, that is a great place to start. Another newer source of free threat intel is MITRE's Twitter account, CVE New. And MITRE is the organization that assigns and manages CVEs. They will tweet out a CVE identifier with a description of the software that it was found in. And that's a really quick and easy way to throw some Python together and start parsing that feed, start getting some value there. But it's important to get the push information set up. We want push alerts. We don't want to go check these things every single day. That's all you'll do with your time. So get those push alerts set up. Get them centralized into one spot. We run the secure@blackberry.com inbox. I know a lot of people use security at their domain. We funnel everything in there. We funnel OSS alerts, researcher reports, end user reports. Everything goes in there for us. It's a really great way to keep continuity. But having that single source is very valuable. But if you're just starting your OSS program, your product's already in market, you've already been racking up a whole bunch of debt along the way. So alerts are great, but they're not going to help you. They're going to help you move forward, but they're not going to help you look backwards, right? So I would recommend for some backlog grooming, we could start with a site like cvedetails.com. It's a really great historical look at everything, vulnerabilities that have popped up in these libraries. They have some data going back to, I think, the 90s for certain libraries. So I think it's a pretty good place to start. So let's head over there. I'm going to use OpenSSL for this example. Hopefully that shows up well. So we're already getting some good data here. We've got a historical look at the number of vulnerabilities that are found in this library, and you're starting to get some detail about what the impact was. But let's dig in a little further. So we look at 2016's vulnerabilities. This is just the very top of the list. It was a very busy year. We get even finer grain details. So we have CV numbers. We have the dates that the CVs were announced. We've got the CVSS score, and they also give you the vector, so you can come to the same conclusion as them, or question the CVSS score if you don't agree. Let's pick one of these and look at it a little more. So now we're getting to the point where we're getting some pretty interesting data. We have, I picked this one, 2016-6309. It looked interesting because it was a nice 10 out of 10 on the CVSS score. But we've got the file that was impacted. We can see the code flaw, which was a use after free. And then we can see the impacts. We've got remote DOS or possibly some code exec. But if we look further down on the same page, we're going to get a big list of URLs that are relevant to the CV. And there's one in the middle that's particularly interesting because it looks like it's going to be the commit that actually fixes this problem, which is some of the most important information. So if we click through, we'll see the commit up at the OpenSSL website. And I think this is a good example because if you look at the bottom of the commit message, you'll actually see the CV right there, which is fantastic. It's growing in popularity to put the CV in the commit message. It's not a standard yet. If the day comes when we can reliably count on that information being there, we can then use commit messages as another source of free threat intel, which will be fantastic. But for now, it's unreliable. And we can see on the right side, we've got the code change required. We've got to define a function and then call it. But we need to figure out if we actually have this change or not. So if we go and look in the file that the patch specified, we can see that we have the function above the function it wants us to define, and we have the code comment below. But we don't actually have that function. And one thing I want to mention is that if you're following the path from the patch, and it says, hey, go look in this directory for this file, and you don't find it, don't give up yet. I've seen numerous times where a file exists with the exact same code, the exact same vulnerability, but someone has moved it to a different directory for whatever reason. So if at first you don't succeed, keep going. Okay, so the code change that fixes the vulnerability isn't there, but are we actually impacted? Well, there's some more steps you can take, right? And one of the things that will often catch you off guard is the amount of dead code that sits in a repository. So it's pretty common that when a developer needs to use a library, the whole library gets pulled in, and really only a couple of files might need to be used. So all that extra code is just sitting there as bloat. So some things to think about. First of all, do you have the file, and do you have the function or the faulty code? And if so, can you prove that it's actually called? Checking to see if code is called can go from very easy to very, very difficult, depending on how nested the library is. So if you're following your client code just down one level to an open source library that you pulled in, not that hard. But just as we use open source in our products, a lot of open source projects will pull in open source from other projects, and you could end up 5 levels down looking at a copy of zlib that you may or may not be calling. So that's when it gets kind of tedious. Other avenues, depending on what language you're writing with. For example, if you're using C, you can go digging through makefiles to figure out if things are actually compiled. I don't particularly like looking at makefiles, so I prefer trying to figure out if things are called or not. And depending on what library you're using, there are a lot of libraries that have pretty extensive configuration files. You may have already configured the library in such a way that you're not using the vulnerable feature, or the vulnerable code cannot possibly be called. So that's definitely another avenue to check out while you're investigating. So let's say we need to take this fix, but how we fix it really depends on how we're using it. So the ideal way to fix a vulnerability is to just take the newest library upgrade available, but it's never that easy. So especially if you're coming to start solving these problems, years after the fact, you're going to be using a very stale version of that library, and trying to upgrade to the newest version is going to cause you to have a really bad day. Your app's going to crash, you're going to have all kinds of regressions, and then it's going to take you a lot of time to step back and figure out what happened, right? Did the API change? The APIs you might be using might be deprecated, or it could be a variety of other things. I've seen people try and upgrade to the newest version, and that failed, and then have them walk back minor version by minor version, trying to figure out what is the newest version that doesn't cause them to have to do any other development work. But at that point, you then need to walk forward and figure out, all right, what are all the vulnerability patches I just rolled back, and then manually apply them. So it's really not an ideal situation. But that brings you to a bit of a major decision point for your program. Are you going to do full library upgrades, put in the development effort to be able to reliably migrate to every new version? Or are you going to go for point fixes and take patches? For us, from my perspective, we take a pretty dynamic approach depending on what we're dealing with. Even in the same product, we might do full library upgrades for one open source project and do point fixes for another. And we're looking at point fixes today. I think they're a little more interesting to demonstrate. So in this instance, we can say that we forked OpenSSL from Git. So we tried to sync to the head of the release branch, and that didn't work out too well for us. So as an alternative, we can cherry pick that one commit, apply it, and move on to the next vulnerability. But hopefully you are able to do a lot of library upgrades if you're coming to products that have been in the market for a while and trying to manage that debt. Otherwise, you're going to have a lot of manual work to do. It's not necessarily fun, but whichever way you choose to go about it, you are proving a lot of value for your company and protecting your customers. So now we're going to look forward to have alerts trigger our investigation, which is a good thing. But at the same time, there's a lot of challenge there. There's no release cycle for this stuff, right? Some newer open source projects are very active and will have defined release schedules for their library, and within those releases they will pick up vulnerability fixes. That's great. You can kind of schedule around that. For a lot of the libraries that we use, they're pretty mature implementations, right? Some of the stuff has been around since the 80s and the 90s, and they've implemented the feature set that would be expected of the library. So they've moved to more of an ad hoc system where they will fix vulnerabilities as they're reported, which is good. But then that makes it a little difficult from an operations perspective of, well, when are you going to have vulnerabilities show up? Well, you're going to have them show up every day, right? There's no Patch Tuesday for OSS. So you kind of always have to be on guard for whatever's going to happen that day. So here's what a slightly updated bill of materials. You can see on the left-hand side, we've added an extra column for the newest available version of the library, so we can track our delta. And then on the right, we've added a bit of notes, and we've also added at least one source of threat intel for each of the libraries that we're using. So if you noticed on the BOM, there was a line item for Django. It is being used to build out our web app variant of our product or service. And Django's pretty awesome because they will tweet whenever they release a new version to support a security fix. So this is a great push alert, and we can use this to kick off an investigation. So if we click through, the link brought us a couple of vulnerabilities. We'll look at just this one, 2016-2512. So we've got a malicious redirect and possible XSS. If we look further down on the same page, we've got favorite information, how to solve the problem. So we've got links here to the full library upgrades for each of the active branches, as well as the individual commits. So let's click through and let's look at one of the commits. Again, another good example, right? We've got the commit message brings us the CVE number right there, so we can be certain that this is relevant. We also have a nice, concise message up there that says this is a security fix, so that's nice. Again, it's a small code change. We're defining a function. Nothing too difficult here. But let's go look at the code. So the patch tells us we need to go look in Django for the utils directory and find the file http.py. So we can go in there and we can see that we haven't actually moved the code that it's asked us to into a function. I believe this file's in pretty core processing that Django does. So if you're coming across a vulnerability in a file that is pretty core to the project, then you can safely assume that it is being used. It's not always the case. If it's in a more obscure component of the project, you'll probably want to follow the steps we outlined earlier to figure out if you're actually calling or compiling the file. So how do we fix? Again, it depends. So I think in most circumstances, people are pulling down Python libraries with pip. So first step is to try a pip upgrade. See if you can upgrade your potentially out-of-date Django package with whatever's the newest. Alternatively, if you forked it from Git, you can follow the same steps, try and sync to the head of whatever release branch you're on. And if that fails, you can then try and cherry pick that commit. If your full upgrade fails through the pip, through the package manager perspective, you don't really have that secondary option. However, you can always use the patch as a guideline, go in and manually edit code, patch it yourself. It's not the ideal way to do things. It is prone to human error. But you do have the fix as a guideline, the official fix. So it's not the end of the world if you have to do a little manual code editing. But these examples, these are kind of the bread and butter of what you're going to need to do over and over again as vulnerabilities are found within the libraries that you use within your product. And you'll repeat these steps many times over the course of your program. But I think it's important to point out that taking a fix and patching your repository doesn't really do anyone any good. It might if you control all of the infrastructure and you only need to patch in one spot. For us and for a lot of people, in order to get a fix out, you must patch your repository, you must compile a new build, test it, ship it to your customers, and then hope that they take that update. And that can be difficult. And then depending on what market you're in, you might have to ship through a regulatory body. So if you're shipping through a regulatory body or someone like a carrier, the time between vulnerability discovery and vulnerability fix, like landing in an actual customer's hands, it can be a very long time. So patching and library upgrades are a great way to reduce the risk of open source within your products, but it's not the only way to go about it. I think I mentioned before, there is the opportunity that duplicate copies of libraries have been introduced in your product. It could be for a number of reasons. It could be for legitimate purposes, like the original library has been configured and mangled in such a way that another dev team can't possibly use it for what they're trying to build. It could be because you have such a big and distributed team that developers weren't coordinating, and you actually have duplicate copies that you don't need, and you can get rid of that second copy, which is great. If you're building a product with a lot of suppliers, something like a hardware product, you're going to end up with multiple copies of quite a few libraries. Your hardware vendor, your SOC vendor will have one copy of the PNG, and your OS provider will have a copy, and they've configured theirs in such a way it doesn't work for you. So then you got to introduce your own copy at the app level, and then at the end of the day, you have a ton of bloat. But any opportunity you can take to get rid of duplicate copies is fantastic. Additionally, I talked about how a lot of times full libraries will be pulled down even though you only need a fraction of that functionality. If you can get rid of that bloat, that's fantastic. We had a really cool example a couple of months ago from a development team within our company. We can't take any credit for it. It was entirely development-led. Their leaders issued them an engineering challenge to see who could have the biggest impact on the shipping product. And they were shipping an APK, and it was about 40 megs in size. And this one clever developer, he went and discovered that they were using a fairly large open source library, but they were really only using a couple of files from it, and he pared that library down to the bare minimum that they needed and cut off 8 megs from their 40 meg binary. So 20% reduction in binary size from one person's efforts over the course of a week. So that was really impressive. That's a nice win-win with engineering. So opportunities like that are pretty golden. And that example gave us a lot of ideas for the future. All right, so like I said, everything we looked at up until now is free. It's stuff that you can go back and start doing on Monday when you get back to the office. However, there are a lot of different ways you can spend some money to make this all easier. The steps I outlined, this is how we started for quite a long time before we got the budget and the maturity to start automating some of this. So first of all, gathering your BOM by hand is not fun. It's a lot easier when you have a vendor where you can take your binary, throw it into their tool, and it builds the BOM for you. So we use Synopsys, and I'll specifically call them out because they're a vendor here. If you want to go talk to them, their products are pretty cool. We use Protect Code. I think that's how you pronounce it. Take your binary, you upload it into their web app. They'll build that bill of materials for you, including licensing, versioning information, everything you'd possibly want. It will also find libraries that you would never find on your own through manual efforts. And some of the specific stuff that is very helpful is the nested libraries. It's really hard to get to the bottom of what each open source project is using within itself and following that chain down. So having a tool that does it for you is amazing. And we've used Synopsys for years, we love them. Threat intel, it is doable to go out and manually find a source of threat intel for each library you're using, but I mentioned we're using about 600 libraries. That's a lot of effort to go and find all those, and they're also not perfect. So we use risk-based security, also a sponsor at the conference. Go talk to them. So they have a nice centralized API that we can call to get all of this awesome data. And we pair that with our bill of materials, and we can almost automatically open investigations. And we know that, all right, so risk-based security brings us a notification that, hey, there's a new OpenSSL vulnerability, and we can go to our BOM and say, all right, we have 70 instances of OpenSSL within our products. Go and open a bunch of investigations so that people can figure out if we're actually vulnerable. Or not to flaunt them too much, but risk-based security does really cool work around finding vulnerabilities that don't actually have a CV assigned. That is a big problem, right? CVs are awesome, but they don't necessarily capture the full scale of vulnerabilities. So it's really fun when you have a great provider of threat intel who brings you data on vulnerabilities that haven't been announced, haven't been publicized, don't have a CV, and you can get those fixed and protect your customers. And it's especially useful if those are vulnerabilities that will soon get a CV, because any one of those could be the next Heartbleed or the next whatever vulnerability your exec is about to ask for. So you can get a week heads up or a month's heads up on fixing those. It's fantastic. And then if you can hire developers to kind of tie this all together, we have a really nice front end for our investigation system that pulls in the feed from risk-based security, pulls in the bill of materials from Synopsys. We have a nice, concise case management tool that we use. I still remember the days before we had that. It was not fun tracking stuff manually. So if you can get those development resources, they're well worth it. But that's it for me. So these are the steps I think that are useful to start managing OSS security debt. If anyone uses these steps to go off and start some kind of program or finds them useful within their company, I'd love to keep in touch. I'll take any questions if anyone has any.
You mentioned that probably when a vulnerability comes out, you kind of pray, please let it be on the server side, because then you can fix it quickly, and your customers don't have any choice as to whether to take the fix or not. But if it is on the client side, how do you force them to upgrade? Yeah, good question.
So at the very end of the day, I don't think you can force them to upgrade.
Sometimes I open my banking app and it says, I'm sorry, you can't log into your banking app right now. You need to upgrade. They force me.
Fair point. So I guess it depends on your industry, right? So for us, we're servicing a lot of highly regulated, financials and governments and things like that. And being able to force updates on them is not a thing that we can do. And they also run very long test cycles. And that's where a lot of difficulty can come in, right? Because we'll have customers who are 3 months through their 6-month test cycle, and they get notice of some new or somewhat new vulnerability, and they say, well, we need to know right now if this vulnerability impacts us or not, because we're ready to throw away 3 months of testing to go to the next version that you've already released, but we're not going to take it for another 9 months. And that's where a lot of frustration comes in, right? And that's why the steady stream of vulnerabilities makes it really difficult to manage customer expectations. But yeah, that's a cool example of blocking people unless they take the update. I can see that working pretty well in the consumer space. But yeah, it's definitely preferential to be able to control as much of that as possible, right? But another avenue through, even if you can't technically force people to take the update, we use advisories as a tool for communicating risk. So we'll publish the advisory and we'll have our customer service people send the advisory notification to our enterprise customers, say, hey, this new vulnerability was found in our product, it's fixed with this version, and here's what we think the risk is. And then we let them contextualize for them, do I need to stop my test cycle so that I can go and take this fix, or can I wait till the next cycle? So it's a non-technical tool, but it is a nice service to alert them of the risk.
From the dev team's perspective, is there something that would have them help you out to make this process easier?
Yeah.
Like, what are some recommendations you make to your own dev teams to say, hey, if you guys did these things, all these CVEs, all these issues would be a lot less impactful, really helping out?
So I think it's going to still be the security team's responsibility to do the monitor and watch of new vulnerabilities, but from the dev perspective, you guys, I think, dev would be in the best position to craft that bill of materials as it's being integrated into the product. So at that point, if there's some kind of OSS committee, some kind of partnership between development and security, and probably legal as well, and some other stakeholders, to know exactly what's in the product as it's coming in. And also, if you can have some kind of gate process where a development team proposes that, hey, we need a copy of this library, if it could go through some kind of vetting process so that stakeholders can have a say, because the security team might have a lot of experience with that library and say, hey, this library, maybe it's not so good to use for these reasons, can we suggest an alternative? Or maybe, hey, we've got another development team in the company, they've already built an alternative in-house, you should use that. But I think development teams are in the best position to have the visibility into what's being used, and that visibility is extremely valuable to security teams. Any other questions? Okay, thank you.